are very excited to bring you this year's Awesome Day online conference. Over the course of the day, you'll learn about the AWS platform, common use cases, and best practices for implementing our services. So why is it important to learn about AWS? As we see more customers moving to the cloud, we are also seeing increased demand in the market for skilled IT professionals who are capable of designing, deploying, and operating applications on AWS. We are hearing this echoed in the media, with the MD of global recruitment website TechnoJobs stating that the demand for cloud skills over the last couple of years has grown by about 20% as companies look to embrace a cloud computing strategy. Indeed.com, a job search service, recently stated that companies posting jobs related to an AWS career continue to grow at 50% compared to other IT jobs over the last year. IT professionals seeking these positions must understand the types of AWS skills and certifications companies want. This presents an enormous opportunity for IT professionals and especially those that are looking to take the next step in their career. IT certifications are considered a gold standard for validating technical proficiency and one's ability to perform on the job. Obtaining certification is often a pathway for IT professionals to move into roles offering expanded responsibilities. Training that leads you toward earning IT certification is becoming more important as people look to grow their careers and customers build institutional knowledge and skills within their organizations. Today, you are taking the first step in your AWS training and certification journey. We'll be providing you with a step-by-step introduction to the core AWS services for compute, storage, database, and networking. My colleague and fellow technical trainer Karthik Chandy will explain key features and use cases, share best practices, and walk through technical demos. Based on the AWS Technical Essentials course, this Awesome Day online conference is one of the best ways for you to learn more about cloud computing and how to get started with the AWS cloud. We have a team of AWS solution architects and technical trainers on hand to answer your questions throughout the day. So please use the chat function to ask them all your technical questions. At AWS, we obsess over our customers. In fact, we created the Awesome Day program based on feedback from our customers. I really appreciate you taking time out of your busy schedule to participate in this Awesome Day online conference and would like to ensure that the event not just meets your expectations, but exceeds them. Please take a few minutes at the end of the event to complete the feedback form. It will help us to make future sessions of the Awesome Day online conference even better. If you complete all of the modules of this Awesome Day online conference, we'll present you with a certificate of attendance. This will be emailed to you within a few days, so look out for it in your inbox. We would love for you to share your thoughts of our Awesome Day online conference on your social media networks via #AwesomeDay. Our objectives today are to expose you to key AWS terminology and concepts, to introduce you to the browser-based AWS Management Console, and to examine the foundational AWS services, including Amazon Elastic Compute Cloud, Amazon Virtual Private Cloud, Elastic Load Balancing, and auto-scaling. Also, we'll provide you with an understanding of AWS security measures and related services such as our Identity and Access Management Service. We'll introduce our database services such as the Amazon Relational Database Service and Amazon DynamoDB. And finally, we'll explore AWS management tools such as Amazon CloudWatch and the AWS Trusted Advisor. In terms of module layout, or how we will structure this session, we will provide an introduction and brief history of AWS, and then we will explore foundational compute, network, and storage services. My colleague Karthik will then take the reins and safely guide you through our modules on security and the identity and access management service, database services, including the relational database service and DynamoDB, services in 2006. More came after, including Amazon Publishing, Amazon Game Studios, Amazon Fresh, and devices such as the Amazon Kindle and the voice-activated Amazon Echo. After over a decade of building and running the highly scalable web application Amazon.com, the company had developed a core competency in operating massive scale technology infrastructure and data centers, and embarked on a much broader mission of serving a new customer segment, developers and businesses, with a platform of web services they can use to build sophisticated, scalable applications. Today, AWS is the fastest growing multi-billion-dollar enterprise IT vendor in the world. AWS, operating now for more than 11 years, is a collection of remote computing services called web services. These web services make up a cloud computing platform offered via the internet. We deliver web-based cloud services for storage, computing, networking, databases, and more. The AWS mission is to enable businesses and developers to use web services to build scalable and sophisticated applications. Web services is another name for what is now commonly referred to as the cloud. AWS is continually expanding its services to support virtually any cloud workload. We develop, iterate, and release products continuously, and the newest products are instantly available to customers. There is no need for customers to upgrade, deploy, or migrate. When a feature or enhancement is ready, we push it out. This approach also enables us to very rapidly introduce and iterate on new services. On this topic of rapid expansion of the AWS platform, as of May 1, 2017, AWS has launched 3,235 new services and updates to existing services. For enterprises, cloud computing with AWS can help IT increase innovation, agility, and resiliency, all while reducing cost. With AWS, you can build enterprise cloud solutions quickly and without upfront investment. The AWS free tier allows you to prototype virtually any application for free. Public sector customers can use our scalable and cost-effective cloud services to meet mandates, reduce costs, drive efficiencies, and accelerate innovation. For startups, AWS frees you to scale quickly usage from hundreds of thousands of customers is aggregated in the cloud, AWS can achieve higher economies of scale, which translates into lower pay-as-you-go prices for customers. Stop guessing capacity. Eliminate guessing about your infrastructure capacity needs. When you make a capacity decision before deploying an application, you often end up either sitting on expensive, idle resources or dealing with limited capacity. With cloud computing, you access as much or as little as you need and scale up and down as required. Increase speed and agility. With cloud computing, new IT resources are only ever a click away, which means this results in a dramatic increase in agility for the organization because the cost and time it takes to experiment and develop is significantly lower. Stop spending money on running and maintaining data centers. Focus on projects that differentiate your business, not the infrastructure. Cloud computing lets you focus on your customers instead of on the heavy lifting of racking, stacking, powering, and cooling servers. Go global in minutes. Easily deploy your application in multiple regions around the world with just a few clicks. This means you can provide lower latency and a better experience for your customers simply and at minimal cost. Each year, research and advisory company Gartner publish a report titled Magic Quadrant for Cloud Infrastructure as a Service. In these reports, AWS is consistently placed as the leader in terms of both completeness of vision and ability to execute. Many of the AWS services and terminology have analogues in the traditional IT space. This side-by-side comparison shows how AWS products and services relate to a traditional IT infrastructure. We will explore some of these AWS services shown here on the right side of the slide in more detail later in this session. AWS Cloud Computing provides a simple way to access servers, storage, databases, and a broad set of application services over the internet. AWS owns and maintains the hardware required for these application services while you provision and use what you need. Let's move on now to explore some of the AWS Foundation and Platform services. As depicted in the slide, AWS Foundation services are categorized into groups, including compute, such as Amazon Elastic Compute Cloud, or EC2, and AWS Lambda. Network, for example, Amazon Virtual Private Cloud. Storage, for example, the Amazon Simple Storage Service. Security and identity services, and application services such as Amazon Workspaces, WorkDocs, and WorkMail. The AWS Platform services represent our broadest collection of services and are categorized, as you can see, from database services through to Internet of Things, or IoT, services. Together with our global infrastructure, the AWS Foundation and Platform services and our ready-to-use applications make it possible for our customers to create and consume an extremely broad and diverse range of workloads in the AWS cloud. I'd now like to share with you some information about the global infrastructure upon which the AWS platform of products and services operates. Firstly, AWS regions are geographic locations that are made up of multiple availability zones. Availability zones consist of data centers clustered in a region. Each availability zone is engineered to be isolated from failures in other availability zones. AWS is steadily expanding its global infrastructure to help customers achieve lower latency and higher throughput, and to ensure that your data resides only in the region that you specify. As you and all customers grow their businesses, AWS will continue to provide infrastructure that meets your global requirements. As of July 2017, AWS operates 44 availability zones within 16 geographic regions around the world, with 5 more regions coming online throughout this and next year. Please refer to the URL on the slide for the latest information on our global infrastructure. AWS products and services are available by region, so you may not see all regions available for a given service. You can run applications and workloads from a region to reduce latency to end users while avoiding the upfront expenses, long-term commitments, and scaling challenges associated with maintaining and operating a global infrastructure. Each AWS region is a separate geographic area that has multiple locations isolated from each other, known as availability zones. Each availability zone is isolated, but the availability zones in a region are network connected through multiple, high-speed, low-latency links. Where natural disasters or fault lines are a consideration, AWS isolates its availability zones so that they are not easily affected at the same time. For example, where earthquakes are a problem, AWS would not build 2 availability zones on the same seismic fault line. If you distribute your resources across multiple availability zones, you can design your application to operate with high availability. In fact, AWS highly recommends that you provision your compute resources across multiple availability zones. If you have multiple compute resources, you can run them across more than one availability zone to achieve added redundancy. If a single AZ has a problem, your assets in a second AZ are unaffected and available. To provide end users with lower latency, AWS uses a global network of 82 edge locations and 11 regional edge caches across 23 countries and 49 cities. These edge locations are used for services such as Amazon CloudFront for content delivery, Amazon Route 53 for DNS name resolution, the AWS Web Application Firewall service, and AWS Shield for denial of service attack mitigation. Both the number of these edge locations and the services that operate from them will continue to increase in number in the future. Now that we have explored the AWS global infrastructure of regions, availability zones, and edge locations, let's take a look at the AWS Management Console. The AWS Management Console is the graphical user interface used to access your AWS account and your resources. Please note, however, that AWS is also accessible through a command line interface, via software development kits, and by a comprehensive collective of APIs for developers. Once you have created your new AWS account via aws.amazon.com, you can sign into the AWS Management Console via this interface. You can sign in with root credentials. However, it's a security best practice to create IAM users and sign in as an IAM user, together with the associated password. Once signed in, you are presented with this interface. You can explore the available AWS services, use our solution builder options to quickly get started with AWS, try out our helpful tutorials and videos, investigate our helpful tips, and explore other topics, all via a single click. You can also provide us with your feedback on the AWS platform, change the console display language, read our privacy policy, and our terms of use. At the top left corner of the Management Console interface, you'll notice our corporate cube icon. This functions as a home button. So no matter where you have navigated to in the console, click here to return to this start page. We offer multiple methods for you to locate our services. You can view recently visited services, such as the VPC service. But remember, you can always return home by clicking the cube. There's also a handy services drop-down menu offering access to all services, either by alphabetical service name or by groupings of related services. You can access your account and billing information or sign out of the console from this menu. You can use the region selection menu to put your focus in the AWS region that you wish to work within for regional and zonal focused services. The support menu provides access to our support center, our public forums, our very comprehensive documentation, and information about AWS training and certification offerings. Click Other Resources to access the AWS Getting Started Resource Center, including a number of tutorials and step-by-step guides. On the menu bar of the Management Console, you'll also find a handy pin tool that lets you drag and drop icons for your frequently used services onto the menu bar. You can reorder these icons to suit your own preferences. Click the pin again to return to normal operations. You can also remove icons if no longer required. Having set up the icons for your frequently used services, they are now only ever a single click away. For each services interface, the left side typically presents a navigation menu of options. Having selected an option, you'll now see a list pane for objects at top and a details pane at bottom, displaying details of the selected item in the list above. The interface changes according to the service that you are working with. There are controls for you to arrange the list and details panes as required. Details for a selected object are typically accessible by a number of tabs. Remember, to return to the starting or home screen, just click the cube icon, which is always at top left. In this module, you have learned about the history of Amazon and AWS, the global infrastructure of AWS, and how to navigate the AWS Management Console. Why not test out some of your new skills? After this session, you can explore some questions highlighting what we have been through so far. This completes our first module. C. Amazon EC2 is our virtual machine service for the AWS cloud. Each virtual machine that you create is referred to as an EC2 instance, as it is an instantiation of the EC2 service. You can choose from a large range of EC2 instance sizes and from a number of operating systems, including Amazon Linux, Red Hat, Ubuntu, SUSE, as well as a wide selection of Microsoft Windows Server operating systems. Amazon EC2 instances are virtualized servers running in AWS data centers. EC2 provides you with complete control of your computing resources and reduces the time required to obtain and boot new server instances to minutes. You can programmatically scale your computing capacity as your requirements change. You pay only for the compute capacity that you actually use. EC2 provides the tools for you to build failure-resilient applications and isolate the applications from common failure scenarios. You can leverage the AWS global infrastructure to deploy across regions and availability zones for reliability. When creating or launching an EC2 instance, decide which region you want to have that instance in. Amazon Machine Images, or AMIs, are templates from which new instances are created and come pre-installed with various AWS API tools which enable, for example, scripting of important provisioning tasks from within an Amazon EC2 instance. All Amazon EC2 instances are assigned a private IP address, and you can choose to also have a public IP address assigned to each EC2 instance. Launching EC2 instances from AMIs results in very fast first boot times. An AMI is a template that contains a software configuration such as an operating system, application server, and applications. You use an AMI to launch an instance, which is the copy of the AMI running as a virtual server on a host computer in Amazon's data center. You can launch as many instances as you want from an AMI, and you can also launch instances from as many AMIs as you need. You can create your own AMI by customizing the instance that you launch from a public AMI and then saving the configuration as a custom AMI for your own use. You can also buy, share, and sell AMIs. You select an AMI based on region, operating system, architecture, launch permissions, and storage requirements for the root volume. Multiple instances of different types can be launched from a single AMI. The instance type determines the hardware of the host computer used for your instance and the virtual hardware that is assigned to the instance. Each instance type offers different compute and memory capabilities. Therefore, you should select an instance type based VPCs in more detail shortly. You can deploy EC2 instances to multiple availability zones within a region. You choose which instance types you want, and then start, terminate, and monitor as many instances as needed, using either the web service APIs or the variety of management tools provided. Amazon EC2 instances can utilize Amazon Elastic Block Store for persistent block-level storage volumes. These EBS volumes must be placed in the same AZ as the EC2 instance that you wish to attach them to. EBS volumes can be saved using snapshots, and additionally, Amazon S3 storage can be used to store data objects needed by your Amazon EC2 instances. With all of these services shown here, customers pay only for the resources that you actually consume or provision, such as instance hours or data transfer. An Amazon EC2 instance can be in one of the following states. Pending, when you first create or launch an instance, or when you start a stopped instance, it enters the pending state. If the instance already exists and was stopped, it is now moved to a new host computer. The instance type specified at launch determines the hardware of the host computer for your instance. The running state. After the pending state, the instance enters the running state. You can connect to your running instance. When your instance is in the running state, you're billed for each hour or partial hour that you keep the instance running. You are billed for all running instances, even if they are idle and not being connected to. The rebooting state. You can reboot your instance through the Amazon EC2 console, the EC2 CLI, and the Amazon EC2 API. It is recommended that you reboot your EC2 instance instead of running the operating system reboot from the instance. When an instance is rebooted, it remains on the same host computer and maintains its public DNS name, private IP address and any data on its instance store volumes. Rebooting an instance doesn't start a new instance billing hour. Shutting down. You will stop incurring charges as soon as an instance enters shutting down or terminated states. An EC2 instance in the shutdown state can be started again if required. Terminated. When you no longer require an instance, you can terminate it. A terminated instance remains visible in the management console for a while before it is deleted. You cannot connect to or recover a terminated instance. As with stopped instances, you will not incur charges for terminated instances. Unlike stopped instances, however, an EC2 instance in the terminated state cannot be started again, as terminating an instance deletes that instance from your inventory of EC2 instances. Stopping. Amazon EBS-backed instances can be stopped. When you stop an instance, it enters the stopping state. Stopped. Amazon EBS-backed instances in the stopped state are no longer eligible for hourly usage or data transfer fees. AWS does charge for the provisioned storage space of EBS volumes on stopped instances. You can modify certain attributes of stopped instances, including the instance type. Starting a stopped instance puts it back into the pending state, which moves the instance to a new host machine. When you stop and start an instance, you lose any data on the instance store volumes on the previous host computer. When launching new EC2 instances, the AWS Marketplace provides you with the opportunity to create your new instance with commercial off-the-shelf software that is automatically installed on your instance, offers charging with the pay-as-you-go model as with Amazon EC2, and centralized billing as charges are included in your monthly AWS bill. The AWS Marketplace currently offers over 4,000 separate software titles from over 1,100 independent software vendors. Choosing the right EC2 instance type is important. We have a wide variety of EC2 compute instance types for you to select from. These run on Intel Xeon processors, which are compatible with the broadest range of ecosystem software and offer high performance and reliability. Each instance type or family is optimized for different workloads or use cases. Within each type or family, we have multiple sizes, for example, large, extra large, 2XL, etc. When you choose your instance type, you should consider the different attributes of each family, such as number of cores, amount of memory, amount and type of storage, network performance, and Intel processor technologies. AWS recently launched C4 compute-optimized instances which utilize Intel's latest 22nm Haswell microarchitecture. C4 instances use custom Intel Xeon V3 processors designed and built especially for AWS. Through its relationship with Intel, AWS provides its customers with the latest and greatest Intel Xeon processors that help in delivering the highest level of processor performance in Amazon EC2. Intel Xeon processors have several other important technology features that can be leveraged by EC2 instances. Intel AVX is perfect for highly parallel, high-performance computing workloads such as life sciences or financial analysis. Intel AES-NI accelerates encryption-decryption of data and therefore reduces the performance penalty that usually comes with encryption. Intel Turbo Boost technology automatically gives you more computing power when your workloads are not fully utilizing all CPU. running in-memory databases such as SAP HANA, big data processing engines like Apache Spark or Presto, and high-performance computing applications. The table in this slide details the associated Intel technologies and storage information for each instance family. Yes, there is a lot of detail in this table. Amazon EC2 lets you choose from several different instance families to meet your computing needs. Each instance provides a predictable amount of dedicated compute capacity and is charged per instance hour consumed. Compute-optimized instances have proportionally more CPU resources than memory and are well suited for compute-intensive applications, whereas memory-optimized instances offer large memory sizes and are well suited for memory-intensive applications. There are also various high storage, GPU-equipped, and very large memory instance types available. EC2 instance metadata is data about your instance and is divided into multiple categories. This metadata can be queried and can be used, for example, to decide how to configure or manage any running EC2 instance. Instance metadata is available from your running instance, thus you do not need to use the Amazon EC2 console or the AWS command line interface to access instance metadata. This can be helpful when you're writing scripts to run from your instance. Note that you are not billed for HTTP requests that are used to retrieve instance metadata or user data. Instance user data is a script that can be specified for an instance, and if so, it will be executed at an instance's first boot. This script can be used to control final specific configuration for your instances that are launched from more generic AMIs. By default. This slide shows an example of user data on Linux. This shell script will install an Apache web server daemon, set it to auto start for each subsequent boot of the instance, and finally start the service for this boot of the instance. For your Microsoft Windows Server instances, you can send user data via a PowerShell script, as shown in the slide, or with a set of Windows batch commands. This enables you to fully configure your Windows Server instances at first boot, most typically via PowerShell. To determine the user data that was executed when an instance was launched, use the EC2 Management Console, or from within the instance, you can use the URI 169.254.169.254/latest/user-data. AWS provides a number of different payment options for the Amazon EC2 service, and thus you're running EC2 instances. Let's examine these options. On-demand instances are free tier eligible. The AWS free tier is a collection of our services that you can use and learn with for your first 12 months for free. Certain capacity and usage limits do apply. On-demand EC2 pricing has no upfront costs, no long-term contracts, and the most flexibility. You pay by the hour or part thereof for your running instances, and no hourly charges apply for stopped or terminated instances. This is great for applications with short-term, spiky, or unpredictable workloads. Amazon EC2 reserved instance pricing allows you to reserve computing capacity for 1 year or 3-year terms at a significantly discounted hourly rate. Reserved instances providing a billing discount and a capacity reservation that is applied to instances to lower your hourly running costs. A reserved instance is not a specific EC2 instance. It is actually a reservation and pricing contract that can float across various EC2 instances of the same type in the same availability zone and region. If you are expecting consistent, heavy use, reserved instances can provide substantial cost savings over owning your own hardware or running only on-demand instances. Scheduled reserved instances enable you to purchase capacity reservations that recur on a daily, weekly, or monthly basis with a specified duration for a 1-year term. You reserve the capacity in advance so that you know it is available when you need it. You pay for the time the instances are scheduled, even if you do not use them. Scheduled instances are a good choice for workloads that do not run cost significantly. The hourly price for a spot instance fluctuates depending on the supply of and the demand for spot instances. Spot instances run whenever your bid exceeds the current market price. Spot instances are a cost-effective choice and ideal for jobs that take a finite time to complete, such as batch processing, encoding and rendering, modeling analysis, and continuous integration. An Amazon EC2 dedicated host is a physical server with EC2 instance capacity fully dedicated to your use. Dedicated instances are physically isolated at the host hardware level from instances that belong to other AWS accounts. Dedicated hosts allow you to use your existing per socket, per core, or per virtual machine software licenses, including Microsoft Windows Server, Microsoft SQL Server, SUSE, and Linux Enterprise Server. Dedicated hosts and dedicated instances can both be used to launch Amazon EC2 instances onto physical servers that are dedicated for your use. There are no performance, security, or physical differences between dedicated instances and instances on dedicated hosts. However, dedicated hosts give you the additional visibility and control over how instances are placed on a physical server. That completes our coverage of Amazon EC2. In this networking section, we'll explore topics covering virtual private clouds, subnets, and network security. With the Amazon Virtual Private Cloud Service, you can define a virtual private network topology that closely resembles a traditional network that you might operate in your own data center. You have complete control over your virtual networking environment, and you can easily customize the network configuration for your virtual private cloud, including selection of IP address range, creation of subnets, configuration of route tables, and network gateways. Each VPC is totally network isolated from all other VPCs. This allows you to build totally separate network environments. For example, a dev and test VPC can be totally separate VPCs are made up of one or more subnets. Subnets exist within AZs, that is, they cannot span across multiple AZs. Just like a VPC, a subnet has a defined private IP address range. The address range for a subnet must be a logical subset of the address range assigned to its parent VPC. Subnets can be private or public. Instances that you place in a private subnet are assigned a private IP address, whereas instances placed in a public subnet have both a private and internet accessible public IP addresses. Public subnets also have a route to an internet gateway, whereas private subnets do not, thus making resources placed within them inaccessible from the internet. Note though that all instances within a specific VPC can communicate with each other via their assigned private IP address and a managed routing service that AWS operates for you between the subnets of your VPC. Shown here in the slide are some examples of VPC usage. For example, you can create a public-facing subnet for your web servers that require access to the internet and place your back-end systems, such as databases or application servers, in a private-facing subnet with no internet access. Additionally, you can create a virtual private network, or VPN, connection between your corporate data center and your VPC, which allows you to leverage the AWS cloud as an extension of your corporate data center. You can leverage multiple layers of security, including security groups and network access control lists, to help control access to your resources in each subnet. Security groups act as a firewall for associated instances, controlling both inbound and outbound traffic at the instance level. Network access control lists act as a firewall for associated subnets, controlling both inbound and outbound traffic at the subnet level. Amazon EC2 uses public key cryptography to encrypt and decrypt login information. Public key cryptography uses a public key to encrypt a piece of data, and the recipient uses the private key to decrypt the data. The private and public keys are known as a key pair. To log into your EC2 instance, you must create a key pair, specify the name of the key pair when you launch the instance, and provide the private key when you connect to the instance. Linux instances have no password, and you use a key pair to log in using SSH. Windows instances require a key pair to obtain the administrator password to log in using RDP. Now that we have explored the features of Amazon EC2 and VPC, let's take a look at the EC2 Management Console. Please note that, as is the case with other AWS products and services, Amazon EC2 is also accessible through a command line interface and via the EC2 API for developers. You can see here that I am signed in to the AWS Management Console, which we demonstrated earlier. In the menu, you can see both who you signed in as and which AWS account you have accessed. I'll demonstrate launching an Amazon EC2 web server instance. So first, I'll access the EC2 console. Then we launch an instance via the EC2 wizard. I'll select an Amazon Linux operating system. Other Linux and Windows Server options are available though. The default instance type is t2.micro, which is suitable for this demo. 1 vCPU and 1 gig of memory. In Instance Details, I'll place the instance in the default VPC that is provided for all customers. This is a great choice for quick demos or non-critical instances. I will place the instance in SID AZA, but B or C are equally appropriate choices. Importantly, for this demo, I want to ensure that the instance is publicly reachable, hence I have service to auto start for future boots, start at the first boot, and install various HTML resources to present a web page. Our Linux web server will have 8 gig of storage, which is sufficient for this demonstration. However, more can be configured if required, either now or later. Let's give the instance a tag of name equals web server, for easy identification in the management console. And here I will create a new security group that will allow only HTTP traffic on TCP port 80 to reach the instance. All other traffic attempting to access this instance will be blocked. Next, a review of settings configured so far is displayed. And finally, I will choose Proceed without a key pair, as I will not need to remote control this instance using SSH. I will only need to browse to it using HTTP. Next, we launch the instance. Whilst the instance is launching, check the instance details, observe its private IP address, refresh the screen, and in a short while, you'll also see the public IP address displayed. We can now use either the public IP address or the instance's public DNS name to browse to our web server. In this case, our web page has been constructed to display various metadata about the instance itself. In 1 minute from clicking Launch Instance, we now have a running web server running on Amazon EC2. That completes this demonstration of Amazon EC2. I hope you found our coverage of core compute and network infrastructure services valuable. Let's now take a look at some of the AWS storage services. In this section, we will introduce you to two key AWS storage services, the Amazon Simple Storage Service, or Amazon S3 as it is known, and Amazon Elastic Block Store, or Amazon EBS. Amazon S3 provides a simple web services interface that can be used to store and retrieve any amount of data at any time from anywhere on the web. It gives any AWS customer access to the same highly scalable, reliable, secure, fast, inexpensive infrastructure that Amazon uses to run its own global network of web applications. There are no limits to the space you can. A bucket is the name of a top-level container that you create in S3 to store objects within. The maximum size of a single object that can be stored in S3 is 5 terabytes. Amazon S3 is designed for 11 nines of durability and 99.99% availability of objects over a given year. You can use HTTP or HTTPS endpoints to store and retrieve any amount of data at any time from anywhere on the web. Importantly, Amazon S3 is highly scalable, reliable, fast, and inexpensive. Some very common use cases for S3 include providing storage for logs, backups, images, documents, AMIs, EBS snapshots, whereas some more advanced use cases include using S3 to store web page assets and to deliver a static website directly from S3. Amazon S3 stores data as objects within buckets. An object is composed of a file and any metadata that describes that file. To store an object in Amazon S3, you upload the file you want to store into a bucket. When you upload a file, you can set permissions on the object and add any metadata. For each bucket, you can control access. In other words, who can create, delete, and list objects in the bucket. You can also view access logs for the bucket and its objects, and choose the geographical region where Amazon S3 will store the bucket and its contents. The Amazon S3.html is the object key. It is important to note that bucket names must be globally unique across all AWS regions and accounts. With Amazon S3, you have total control of who has what access to each object you store in S3. Encryption of data in transit to and from S3 is possible via the SSL encrypted endpoints for the S3 service. The encrypted endpoints are accessible both from the internet and from within AWS, so that data can be transferred securely both within AWS and to and from sources outside of AWS. Encryption of data at rest within S3 is available via a number of methods, and at no extra cost to storing data unencrypted. Customers who prefer to manage their own encryption keys can encrypt data before uploading to Amazon S3. Alternatively, you can use Amazon S3 server-side encryption if you prefer to have Amazon S3 manage encryption keys for you. With Amazon S3 server-side encryption, encryption happens automatically when data is written to S3, and decryption happens automatically when data is retrieved. Versioning is an S3 feature for keeping multiple variants of an object in the same bucket. You can use versioning to preserve, retrieve, and restore every version of every object stored in your Amazon S3 bucket. Lifecycle management defines how Amazon S3 manages objects during their lifetime. Some objects that you store in an S3 bucket might have a well-defined lifecycle. For example, if you are uploading periodic logs to your bucket, your application might need these logs for a week or a month after creation, and after that you might want to delete them. Some documents are frequently accessed for a limited period of time. After that, you might not need real-time access to these objects, but you might need to archive them for a longer period and then, optionally, delete them. Financial and healthcare records, long-term database backups, and data that must be retained for regulatory compliance are some of the kinds of Amazon Glacier, or have them permanently deleted. S3 infrequent access is useful for data such as backups and other older, infrequently accessed data where high performance continues to be a requirement. Pricing for Amazon S3 is made up of consumed storage pricing and request and data transfer pricing. With storage pricing, hello and welcome to the AWS MACIE. The table displayed here details 3 storage classes that are available for S3 objects. Every object in Amazon S3 has a storage class associated with it. S3 For even greater durability, if required, these snapshots can be replicated to another region of your choice. EBS volumes can be attached to any instance in the same availability zone as the volume. Volumes attached to an EC2 instance are exposed as storage volumes that persist independently from the life of the instance. When EBS volumes are not attached to an EC2 instance, you pay only for the cost of storage based on provisioned size. Amazon EBS provides various volume types, which differ in performance characteristics and price, so that you can tailor your storage performance and cost to the needs of your applications. The volume types fall into 2 categories: solid-state drive-backed and magnetic hard disk drive-backed volumes. This table displays the characteristics of the different EBS volume types that are available for you to select when creating new EBS volumes. You can attach multiple EBS volumes to the same EC2 instance, but each volume can be attached to only one EC2 instance at a point in time. EBS volumes behave like raw, unformatted block devices. You can create a file system on top of these volumes, or use them in any other way you would use a block device like a hard drive. Amazon EBS is particularly helpful for database-style applications that frequently encounter many random reads and writes across the dataset. You should think of an EBS volume as simply a virtual hard drive. So a great use case for Amazon EBS is when you want the hard drive to persist past the life of the Amazon EC2 instance. EBS volumes are ideal for root volumes for your instance operating system, for database storage, and datasets that are up to 16 terabytes in size. Please note that Amazon EBS pricing is based on allocated storage. This is unlike Amazon S3, where pricing is based on space actually consumed. Additional charges apply for EBS with provisioned IOPS. Amazon EBS volumes are designed to be highly available and reliable. EBS volume data is replicated across duplicate storage systems within a single availability zone that you select when you create an EBS volume. This replication prevents the loss of data from the failure of any single component. Because EBS volumes are replicated within a single availability zone, establishing mirroring of data across multiple EBS volumes from within your EC2 instance's operating system will not significantly improve volume durability and is therefore not required. EBS volumes must be in the same availability zone as an instance to enable attachment. You can create point-in-time consistent snapshots of your EBS volumes to establish even greater durability than what is provided by a single AZ. EBS snapshots are stored in Amazon S3 and automatically replicated across multiple availability zones within a region. If required, you can even replicate these snapshots to other AWS regions for even greater levels of durability. The table in this slide illustrates the significant differences between Amazon S3 and Amazon EBS. EBS volumes are network-attached hard drives that can be written to or read from at a block level. Amazon S3 is an internet-accessible, object-level storage service. This means that you must write whole objects to S3 at a time. If you change one small part of a file, you must still rewrite the entire file in order to commit the change to Amazon S3. This can be time-consuming if you have frequent writes to the same object. S3 is optimized for write once, read many use cases. The other major difference is cost. With Amazon S3, you pay for what you use, and with Amazon EBS, you pay for what you provision. EC2 Instance Storage provides temporary block-level storage for your EC2 instances. This storage is located on disks that are physically attached to the host computer running your EC2 instance. Instant Store is ideal for temporary storage of information that changes frequently, such as page files, buffers, caches, scratch data, and other temporary content, or for data that is replicated across a fleet of instances, such as a load-balanced pool of web servers. Instant storage is very fast, it is free, but its contents do not persist if you stop and then later start an EC2 instance. The use case for local instant store is for temporary data only. For data that requires a higher level of durability, use Amazon EBS volumes or back up the data to Amazon S3. Finally, the table in this slide shows key differences between rebooting, stopping, and terminating your instance, including data persistence for Instant Store and EBS volumes. Awesome. In this second module, you learned about the key infrastructure services offered by AWS, including compute, network, and storage services. After this session, you can explore these questions highlighting what we have been through so far. Next up, I will be handing over to Karthik, who will take you through the remaining content for today's Awesome Day online conference. Thank you, and stay tuned.
and welcome to Module 3. My name is Karthik Chandy. I am a technical trainer with AWS. Storage and networks are handled by AWS. Security of the global infrastructure consisting of regions, availability zones, and edge locations are also handled by AWS. Customers manage security in the cloud. This includes patching operating systems and applications, securing access through firewall ports, and encrypting data where needed. Let's look into some of the physical security aspects managed by AWS. All AWS data centers are managed by trained security staff. These data centers are located in nondescript locations, and all staff working in these data centers have to be authorized and go through multiple layers of security. In addition, all server access is controlled through bastion or jump servers. Firewall devices block and or TLS. Security groups can be configured to restrict unauthorized access by permitting specific system access through well-defined ports. In this example, the web servers can be accessed over the internet and the app servers can only be accessed by systems in the web tier. Similarly, systems in the database tier can only be accessed by the app tier. All SSH and RDP access has been restricted to the corporate network's IP addresses. Let's move on to the AWS Identity and Access Management section. In this section, we will cover four main aspects: users, groups, policies, and roles. AWS Identity and Access Management, or IAM, is mainly used for two reasons. They are authentication and authorization. Let's start with authentication. When a user tries to log in to the management console, they are required to enter a username and a password. If a user prefers to use the AWS CLI, SDK, or API, they are required to authenticate using an access key and a secret access key. Every IAM user can be securely identified using their credentials. As the number of users grow, it is recommended to create groups, as the groups help manage users more efficiently. Permissions for users and groups can be configured in AWS IAM using a policy. A policy is defined using a JSON document and can be applied to users, groups, or roles. We will cover IAM roles a little later in this module. An IAM policy consists of several elements. In this policy, you can see two statements defined as SID. We can interpret the first SID as anyone using this policy is allowed as defined under effect to describe start and stop as defined under action, any instance as defined under resources, provided they log in from a specific IP address as defined under condition. The second statement permits downloading objects as defined by S3 get object from a bucket called example_bucket. Let us refer to the JSON policy using the AWS IAM policy icon. The AWS IAM policy can now be assigned to an IAM user or an IAM group. All users and groups using this policy will now be limited to the permissions defined in the policy. A policy may also be assigned to an IAM role. IAM roles, however, do not support long-term credentials like an IAM user. Credentials for an IAM role are only valid for a short period and can be renewed by a service called the AWS Security Token Service. These temporary credentials can now be used by an IAM user or another AWS resource by assuming the IAM role. Let's look at an example. Imagine you are hosting a Python application inside an Amazon EC2 instance. How would you permit the Python application to interact with the Amazon S3 bucket? One way is to embed the IAM credentials into the Python code. However, is this the right approach? A better option would be to use an IAM role that can be assigned to the EC2 instance as an instance profile. Let's look at an example. In step 1, when creating an instance, choose an AWS IAM role. In step 2, after creating the instance, log into the instance and install the Python application along with the AWS SDK for Python. The AWS SDK for Python would enable interaction with AWS services such as Amazon S3. It is important to note that as we are using an IAM role, AWS credentials don't have to be included in the Python code. In step 3, when the Python application tries to interact with an AWS service, credentials will be needed. However, as credentials were not included in the Python code, the AWS SDK would communicate with the Amazon EC2 metadata service that is accessible using the 169.254.169.254 address. The Amazon EC2 metadata service communicates with the AWS Security Token Service to gain access to temporary credentials. Finally, in step 4, the Python application uses the temporary credentials provided by the IAM role to communicate with Amazon S3. Temporary credentials consist of an access key, a secret access key, a session token, and a time to live option, which can be defined by the administrator. Some of the common use cases for temporary credentials are single sign-on federation, mobile user access, and cross-account authentication. Please note, AWS IAM authentication does not apply to OS or application authentication. Some of the best practices for AWS IAM are similar to the ones we use at our workplace today. Never provide root access for daily administration. Always grant users with least privilege, or even better, delegate permissions using IAM roles. As the user base increases, consider using groups to manage multiple users. Use multi-factor authentication. Have a strong password policy, etc. Rotate credentials for programmatic access. Use conditions in policies to make them more stringent. Monitor user activity, and so on. Let us now look at an AWS IAM demo. On the AWS Management Console, we click on IAM. To the left of your screen, on the AWS IAM console, we have a few options to choose from. Let's click on Policies. Here you see the AWS managed policies. Let us create a policy using the AWS Policy Generator Wizard. We start with the Allow option and choose Amazon S3 under AWS Services. Under Actions, we could allow all list operations. Rather than selecting all the list operations, let us select one for now and update the policy later. Further, under Amazon Resource Name, we use the star while character. On the Amazon S3 console, we have a bucket which contains a folder labeled public. The folder contains a picture, and the same picture is also stored on the root of the bucket. Let's create a second statement in AWS IAM for Amazon S3. Under Action, let's choose the getObject operation to permit download. For Amazon Resource Name or ARN, let's follow the documentation to learn more about the structure. The ARN always starts with ARN followed by AWS and the service in use. In our example, we will use S3 followed by the bucket name /folder and /star to indicate all objects under the policy. Now let's create a statement for Amazon EC2. Under Actions, we select all describe and get actions along with the options to start and stop instances. Finally, under ARN, let's use star to indicate all instances and click on Next Step. Let's give the policy a name, a description, and let's replace S3:list bucket with S3:list star, which indicates all list operations. We then validate the policy and create the policy. The policy can be listed using the customer managed filter. Let's create a group called Team1 and attach the policy we earlier created. After we create the group, we proceed to create users. Because the user1 will only need console access, we select the appropriate option. The user is provided with a password and now can be prompted to enter a new password if needed. We now add the user to the group, making sure they have the right permissions. Login details can now also be emailed to the user. For this example, we will copy the login URL and use another browser to simulate the new user login. You you notice the user account is specified and the user only enters the login credentials. Tries to start an instance, it should be successful. Similarly, a stop operation should also be permitted. Let's now move to the Amazon S3 console. As per the policy, the user should be permitted to list all the buckets and their contents. However, any option to download objects should fail unless it is a public folder in the demo bucket. As expected, the picture was successfully downloaded. We have now completed Module 3. Please test your knowledge by answering the questions on the screen. Columns. In a NoSQL database, there is a partially defined schema. A JSON document is an example of NoSQL data. Another important difference is to note that relational databases scale vertically, whereas NoSQL databases can scale horizontally, making them more flexible. Some of the factors one must consider when choosing a database are: what is the structure of data being stored? What kind of queries would the database receive? what is the total size of data, and what is the size of each item in the database, and what is the frequency of data access, etc. Amazon RDS is a managed service that supports some of the prominent relational database engines. Many relational database administrators, or DBAs, spend their time installing, maintaining, and patching their databases. They also spend time improving their business by optimizing data. This helps differentiate their organization by focusing on their core competencies. Most DBAs would agree that the time they spend building functionality and improving their data for their business is where they find the most value on the job. Amazon RDS is the answer to this. It offers the ability to offload all that undifferentiated heavy lifting, the installations, patching, and other maintenance tasks, so all you have to do is the work related to the growth of your business. Amazon RDS is a cost-efficient and resizable solution. It allows you to offload the time-consuming standard database administrative tasks while giving you the full capability of MySQL, PostgreSQL, Oracle, SQL Server, MariaDB, and Amazon Aurora. Each one of these databases, depending on the workload or use case, allows you to get access to the capabilities of a relational database without having to manage setup and maintenance tasks. Amazon RDS is easy to set up, operate, and scale because you're offloading this work to AWS. Amazon RDS also manages patching and backups, so you don't have to do that work yourself. You benefit from the flexibility of being able to scale the compute resources or storage capacity associated with your relational instance via a single API call. An RDS instance is like an Amazon EC2 instance. After you select a database engine, you can create multiple databases on the instance. Your RDS instance can also be launched inside a VPC, securing access of your system. RDS supports both automatic backups and manual snapshots. An automatic backup follows a journal-based backup method. It gives the user greater granularity, but it might take a long time to restore some backups. A manual snapshot is like an Amazon EBS snapshot. It is an independent copy and supports incremental backups. RDS snapshots can be migrated to another AWS region, after which a new Amazon RDS instance can be created from the snapshot. Amazon RDS supports a wide variety of security options. Amazon VPC prevents external users and systems from accessing Amazon RDS instances. AWS IAM policies can be used to restrict certain operations. For example, if you would like your developers to have the ability to create small Amazon RDS instances and prevent them from creating large DB instances, AWS IAM can help. Amazon RDS supports data encryption for data at rest and data in transit. On Oracle and Microsoft SQL Server RDS instances, transparent data encryption is supported. With the multi-AZ architecture in place, should one of the availability zones fail, the database would eventually be available for application access. Like any database, Some of the common best practices for Amazon RDS are to ensure multi-AZ deployments are configured, RDS instances are hosted in private subnets, maintenance and backup windows are properly configured, and depending on the expected database performance, ensuring the right instance type, storage capacity, and IOPS are allocated will ensure user satisfaction. Setting up a time to live on application servers to 30 seconds will ensure a failover from the master to standby transitions smoothly. Let's look at a demo of Amazon RDS. On the management console, let's click on RDS. To create an Amazon C, inside which the Amazon RDS instance should be created. For the availability zone section, let's select the availability zone and the corresponding subnet that Amazon RDS should use. This ensures multiple availability zones are selected. Moving on, let's click on Instances and Launch DB Instance to create a new DB instance. Amazon RDS offers a variety of database engines. In this demo, we will use MySQL. Let's choose the production option for a multi-zone deployment. We can also choose the version of MySQL, and like Amazon EC2 instances, we can also select a preferred instance type. We can specify if multi-availability zones should be configured along with the storage configuration. Let's provide a username and a password for user login and click on Next. On the Configure Advanced settings, we can specify a VPC and a subnet group that should be used. We can specify if the database needs to be a publicly accessible one and what security group should be used. As this is a MySQL database, I will use a MySQL-based security group. We can give the database a name, specify parameter configurations, and enable encryption if needed. We can configure backup and maintenance if needed. Some of these operations are similar to creating an Amazon EC2 instance. Finally, we click on Launch DB Instance. This step should take some time to complete. While the database is being created, let's switch to the Amazon EC2 console, where a web server has been created with some user data configuration. The user data configures a web server and downloads a sample web page. This web server can connect to the DB instance once it is ready. Let's click on RDS and enter some of the DB values while we wait for the DB to be created. The DB instance is now ready with an endpoint. Let's copy the endpoint and paste it in the web server page. Making sure we get rid of the colon and the port number at the end of the string. Let's now click on Submit on the web server page to connect to the DB. We can now interact with the database by adding or editing some entries in the database. This is the end of the RDS demo. Let's now move on to the next section. Amazon DynamoDB is a fully managed NoSQL database service. An Amazon DynamoDB table consists of items and attributes. In this example, a table called music has been created with multiple attributes, namely artist, song title, album title, year, and genre. Notice the number of attributes in every item is not uniform. Some have more and some have less attributes. The only attribute in a table that is mandatory is a primary key. The primary key has to be unique throughout the table. Further, there are two types of primary keys. Partition key based primary key, where the single attribute is unique, or a partition and sort key based primary key that forms a unique combination. Provision throughput enables administrators to specify the kind of performance needed in terms of capacity units. A query operation helps administrators search from an index based on a partition key. If you would like to search for information that is not indexed, then you could consider using a scan operation. Scan operation looks through all attributes in a table. Let's now look at an Amazon DynamoDB demo. We start by selecting Amazon DynamoDB on the management console. Creating an Amazon DynamoDB table is simple. On the DynamoDB dashboard, let's start by clicking on Tables. We then click on Create Table and name the table as Music. For the primary key, let's choose Artist as the partition key and add a sort key with the label as Song Title. We could simply click on Create Table to create a table. However, let's uncheck the Use Default Settings option. Amazon DynamoDB supports auto-scaling, but for this example, let's define the read and write capacity units as 1 respectively. And that is all you need to create the table. The table should take a few minutes to be ready. In the meantime, here is a sample JSON document with some entries such as a song title, artist, album title, etc. We will use a batch write option to write all these entries into the table using one single command once the music table is ready. Now that the table is ready, let's click on the Items tab and refresh to verify that the table has no data. On the terminal, I will use the batch write item command to write the JSON data into the table. The operation was successful. Let's verify the same on the management console. And after refreshing, you see all the data in the table. We can use the query operation to search based on primary key values a scan operation for any attribute in the table. This is the end of the DynamoDB demo. In summary, if you are looking for a managed relational database service and the database engine you are looking for if you need access to the operating system hosting your DB, or you want to choose an unsupported DB engine or version, then hosting a database on Amazon EC2 would be ideal. Thank you for listening. We have now completed Module 4. Please test your knowledge by answering the questions on the screen. Or more requests. This does not mean we over-provision in advance. Rather, how do we scale on demand is a good question. Amazon CloudWatch, auto-scaling, and elastic load balancing, or ELB, form a triad of services that can assist with scaling. Amazon CloudWatch is a monitoring service for AWS cloud resources and the applications you run on AWS. Amazon CloudWatch supports a variety of metrics. In this example, Amazon CloudWatch is shown monitoring ELB latency and CPU utilization of Amazon EC2 instances. When an Amazon CloudWatch alarm is triggered, a corresponding auto-scaling policy is triggered to create a new instance. The instance is then added to the auto-scaling group. Remember to create at least two auto-scaling policies, one to scale out and the other to scale in. Finally, auto-scaling notifies the ELB that a new instance has been added to the group, after which the ELB starts to distribute load to the newly created instance. This way, all the three AWS services complement one another to efficiently scale an application. ELB helps distribute traffic across multiple instances or containers. Let us learn more about ELB. There are two types of ELB. The first is a classic load balancer that monitors the health of back layer of the OSI model. The application load balancer or ALB can distribute traffic to backend targets based on the path. For example, all traffic to example.com would go to the first target group. Traffic to example.com/API would go to the second target group, and traffic to example.com/mobile would be distributed to the third target group. Let us learn more about Amazon CloudWatch. Amazon CloudWatch metrics can be viewed on the management console or accessed using the AWS CLI. Let us familiarize ourselves with some Amazon CloudWatch terms. Standard metrics offered by Amazon CloudWatch are complementary. You can create custom metrics if the required metric is not a standard metric. Some examples of custom metrics are number of web page views, memory utilization on an Amazon EC2 instance, or JBoss utilization of an application. Amazon CloudWatch offers integration with many third-party tools such as Nagios, Splunk, and Datadog, to name a few. Amazon CloudWatch alarms can be used to notify administrators about an event such as an instance creation or a new job in an Amazon SQS queue. In addition to standard email, Amazon CloudWatch can integrate with Amazon SNS that supports HTTP and SMS, among other options. From our earlier discussion, we learned that Amazon CloudWatch enables auto-scaling to dynamically determine the right time to scale an auto-scaling group. Autoscaling is a web service designed to launch or terminate Amazon EC2 instances automatically based on user-defined policies, schedules, and health checks. Setting up autoscaling involves 3 steps. The first step is to create a launch configuration. You will notice the options specified here are the same you would have used to create a new instance. In other words, at this stage, you help autoscaling determine what kind of instance should it create. The next time a scaling requirement arises. An autoscaling group is a logical group of autoscaling instances. When an autoscaling group is created, we would have to specify the VPC and subnets autoscaling should use. We also specify the minimum and the maximum sizes of the group. Autoscaling will ensure that minimum number is maintained by creating new instances to maintain If a desired capacity is not specified, then the minimum size becomes the desired capacity. The maximum size refers to the limit of the number of servers in the group. Depending on the traffic directed to the application, Amazon EC2 instances from the group before terminating it. In summary, Amazon CloudWatch, auto-scaling, and ELB can be used to work together to ensure a little later in an auto-scaling group. After giving the AMI a name and a description, let's click on Create Image. AMI creation will take some time, and its progress can be verified by clicking on AMIs on the EC2 dashboard. Let's now create an application load balancer. We start by giving the load balancer a name. We can specify if the load balancer should be publicly accessible and what port should be open. We create a target group that will consist of Amazon EC2 instances from the auto-scaling group. Targets will be later registered once the auto-scaling group has been created. After reviewing the options, we click on Create. Let's verify if the AMI is ready. While the AMI is being created, let's proceed to the auto-scaling configuration. We start by creating a launch configuration and then proceed to select the web server AMI. Let's click on Next, Configure Details, and give the launch configuration a name. We then enable detail monitoring, and since the web service will not be publicly exposed, we can choose the Do Not Assign a Public IP Address to Any Instance option. the option to receive traffic from the ELB. We also enable ELB health check and detailed monitoring. In the Create Autoscaling Group section, let's create an autoscaling policy to scale between 2 and 6 instances. In the Increase Autoscaling Policy section, let's define the average CPU utilization to be greater than or equal to 60% and name the alarm as scale-out. We then specify the action to add one instance and the warm-up period as 60 seconds. We similarly create a scale-in alarm with the CPU utilization to be less than or equal to 20%. Let's call the alarm scale-in. Let's choose the option to remove one instance if the condition is true. Scaling groups or instances on the EC2 dashboard. Let's click on Target Groups and make sure the targets are healthy. After verifying the status, we can go to the load balancers This should take some time to reflect in CloudWatch as an alarm. You will notice the alarms transition from scale-in alarm to an OK state, and finally the scale-out alarm would be triggered. It could take some time for the scale-out alarm to be triggered. Once the scale-out alarm has been triggered, autoscaling should add another instance to the autoscaling group. Let's check the autoscaling group to verify if a new instance has been created. This concludes the autoscaling demo. We have now completed Module 5. Please test your knowledge by answering the questions on the screen. Congratulations! You have now completed the Awesome Day online conference. Now that you understand the basics of AWS, it's important to continue learning, and there are a few things that I would like to ask you to do. To gain some hands-on experience, try the complimentary AWS introductory labs. These labs provide you with hands-on practice in a live console and generally take less than 30 minutes to complete. There are also a large number of advanced labs if you would like to dive into a bit more detail. please go to amazon.quicklabs.com. Once you're on the amazon.quicklabs.com login page, please click on Join to create a new account. After creating an account, please click on Sign in and log into QuickLabs using your login credentials. After logging into QuickLabs, please click on the menu option and then you can click on Catalog, where you will find a set of quests or labs to choose from. A quest contains a series of labs based on technologies or services. Some quests even help prepare you for certification. You can alternatively choose individual labs by clicking on Labs. Under Labs, you will find labs with a title, the level of complexity, and the time required to complete the lab. You will also find the cost of each lab. As you can see, there are some labs that are free. You can search if a lab on any Amazon service is available by using the search option. I will search for Amazon S3, and you will find there are a few labs on Amazon S3, one of which is a free lab. Please start by reading the lab overview to make sure you're interested to proceed. If you would like to proceed, please click on Start Lab. Once the lab has been started, you can follow the remaining instructions. To log into the management console, click on Open Console. On the management console, you can verify your login and you start by creating a bucket, then upload an object, make sure the right permissions are configured, and finally enable versioning. First task is to create a bucket. Please follow the instructions on QuickLabs. On the management console, search for S3. You can then click on Create Bucket and enter a unique bucket name, such as lab-your initials. If the bucket name is not available, please use additional characters for the bucket name. After you follow the remaining steps in the lab guide, you should be able to create a bucket. In task 2, you would upload an object and then you would make the object public. After you complete the lab, please sign out of the management console. And on the Quick Lab screen, click on End Lab. Thank you for watching. This is the end of the Quick Lab demo. Once you have completed the labs, check out the list of AWS instructor-led classes that we offer. Our classes are taught by AWS trainers, and we offer beginner, intermediate, advanced, and specialty courses. And the final step is getting AWS certified. As John mentioned in the opening, there is a huge demand for AWS skills within the market. AWS certifications recognize IT professionals with the technical skills and expertise to design, deploy, and operate applications and infrastructure on AWS. Check out aws.amazon.com/training. Thank you once again for taking part in Awesome Day Online Conference. We hope that you had an awesome time.